Alright, we'll take a look at distance, midpoint, and circles here in our first section. And we'll talk about the distance formula to begin with. It says the distance d between any 2 points, x1, y1, x2, y2, is given by the formula d equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So square root of change in x squared was change in y squared. And we can prove that looking at a little bit of geometry together. So what I want to do is just show you a picture. Let's draw in the ordered pairs on this rectangular coordinate system, this xy axis. So let's pick 2 points. So say we have point 1 right here. And over here we got point 2. So as we label these, go ahead and label them. x1, y1, there's point 1. And then point 2, we got x2, y2. Well, if we're looking at the distance between those points, right, let's go ahead and look at what we do know. Right, we can find the horizontal and the vertical distance easily. So what I want to do is go ahead and draw in the horizontal and vertical distance. Right, so when we do that, we form what? A right triangle. And you can see in this right triangle, what we're looking for is the hypotenuse. Right, here's the distance d between those 2 ordered pairs on this line segment. So if we want to find this distance, we can do so using some right triangle geometry. One thing we know about the horizontal and vertical distance, right? If we want to know the horizontal distance, how far have we moved along the x-axis? So if we've gone from x1 to x2, we've gone a distance of x2 minus x1 units. Right, there's the horizontal distance. And the vertical distance, right, we would subtract the y coordinates, y2 minus y1. Right, we're looking at where we moved on the y-axis. We've gone up from y1 to y2. So with that said, distance, again, let's apply the Pythagorean theorem now. So in the Pythagorean theorem, reviewing our geometry, we know that the square, right, of our hypotenuse always equals the sum of the squares of 2 legs. So our hypotenuse, which is d, so d squared is equal to the sum of squares of the 2 legs, which are given by the horizontal distance of x2 minus x1 squared, plus the vertical distance would be the other leg in the right triangle. We square it. So there's the Pythagorean theorem. Hypotenuse squared equals the sum of squares of the 2 legs of the right triangle. And then you can see as we solve for d, right, we can take the square root to get it. So in the end, our distance formula, right, comes from our Pythagorean theorem. D is equal to the square root of change in x squared plus the change in y squared. All right, so I just wanted to show you a little background. So you go down here to the example below. It says find the distance between the given pair of points, given an exact answer and where appropriate, approximate to 3 decimal places. So what I'd like to do is just go ahead and draw in a quick picture. So let's get a visual. Let's draw in our x and y axis. And as we go to -4, -7, left 4 units, down 7. So down here is our ordered pair, -4, -7. And then -1, 3 would be left 1, up 3. So somewhere over here in quad 2. Be that ordered pair. And we connect these, right, to see our line segment. So we want to know what the distance between these 2 points is. We want to find d. And again, you can prove it, right? If we wanted to prove that, of course, we could easily see our horizontal and vertical distance, right? So what is the horizontal distance? So we're moving from negative 4 on the x-axis, over here to negative 1 on the x-axis, we're going horizontally 3 units to the right, which is what? The change in the x-coordinates. Right? That's equal to x2 minus x1. That's equal to negative 1, right, minus negative 4. Right? So negative 1 minus negative 4 is negative 1 plus 4, which is 3. Just want to show you that horizontal distance. And then, of course, that's the horizontal distance. Alright, let's go ahead and look at the vertical distance. So to find the vertical distance, we're looking on the y-axis. So we've gone from negative 7 on the y-axis up to 3. So vertically, we've gone up 10 units. Right? That's equal to y2 minus y1. Right? You subtract the y coordinates, you get 3 minus negative 7. So 3 minus negative 7 is what? 3 plus 7, or 10. So again, there it is. And then if you wanted to find d, right, so if we're going to find our value of d, the distance, we could use the Pythagorean theorem to prove it. Alright, so let's go ahead and show it. Alright, we'll go ahead and prove it here. So again, the Pythagorean theorem, the square of the hypotenuse, d squared, equal the sum of the squares of the two legs, 3 squared plus 10 squared. Alright, change in x plus the change in y, the horizontal and vertical distance. And then what we're going to do is take the square root of both sides. We have our distance d, the square root of what? 9 plus 100, or the square root of 109 for a value of d. Now that's our exact. Get your calculator out. Let's put in square root of 109, 10.44, right, for our value. Rounded to 3 decimal places. Let's go back, 10.440. So 10.440 for our distance rounded. So that's the approximation. So again, here's the exact, right, distance. And here's the approximate. So that's what they're asking for. So be careful as you're working these. Right? They'll ask for sometimes exact value, of course. It's a irrational root. It's a rounded decimal. But they might want you to round some of them to certain decimal place value. Now again, you got your formula also. So I'm not big on just plugging numbers in the formula. I always like to show you where it comes from. But if you were to use your formula, right, let's go back to what we just proved earlier. Distance formula, d is equal to the square root, change in x squared, plus the change in y squared. So in this problem here, you could have labeled it, right? There's your points. There's x1, there's y1, there's x2, and there's y2. So using the distance formula, d would equal the square root, change in x, negative 1 minus negative 4 squared, plus the change in y, and y2 minus y1 is 3 minus negative 7 squared. And we simplify, we get negative 1 minus negative 4, which simplifies to what? 2 negatives make a positive. So that makes a 3. And 3 minus negative 7, we simplify that. Right, 2 negatives make a positive, so that ends up being a 10. Right, so we got 3 squared plus 10 squared, which, yeah, is equal to the square root of 9 plus 100. Square root of 109. Right, which again, approximately 10.440. So again, that's distance using your formula. So you got your formulas, but I do want to show you where it comes from. It's always nice to see a little background, a little proof, right, as we're looking for finding the distance. So I wanted to show that to you also. Right? So let's do another one. Let's look at our next example. Now, as we move on to example B, so we continue our topic here, looking at distance. It says use the distance formula in the Pythagorean theorem, which we've talked about, improving our distance formula, to determine whether the set of points could be vertices of a right triangle. So I want to prove whether or not these three ordered pairs are the vertices of a triangle with a 90-degree angle in it, right triangle. So what I'd like to do first, just to see it, let's get a picture. Let's go ahead and draw in the triangle they give us. So -3, 1, left 3, up 1. So we're here in quad 2 is a vertex for this triangle. 2, -1, right 2, down 1. Here's another vertex. And then 6, 9, right 6 units, up 9, somewhere up here, and quad 1 is the third vertex. So we can go ahead and connect these. Alright. And we can form our triangle. So you see a picture of it. Now, our question is this. Is this a 90-degree angle? Right? Is it a right triangle? So that's our question at hand. Right? Do we have a right triangle in front of us? Right? Now again, with a right triangle, we know the Pythagorean theorem would hold true. So let's go ahead and label these three lengths. So D1, I'll call this D2 and D3. So our question, of course, the longest side, which would be D1, that would have to be the hypotenuse. So will D1 squared equal D2 squared plus D3 squared? Right? We know the Pythagorean theorem would have to hold true. Right? So that's what we got to prove. That's our work in this example. So let's go see. So let's find these three lengths. So that's our question at hand, is the right triangle. So what is D1? So let's go ahead and use our distance formula. So D1 is equal to the square root of the change in x squared. So again, looking at our ordered pair here, right, going from 6, 9. So there's our x coordinates, right? So we want to subtract those. So I got 6 minus -3 squared plus the change in the y coordinates. There's the y values. So plus 9 minus 1 squared, right, for the change in y. And let's go ahead and simplify. So we're finding our horizontal and vertical distance. We know this comes from the Pythagorean theorem. We've proved it already. Or 6 minus -3, that's what? 6 plus 3. There's two negatives. Make it positive. So we end up again with 6 plus 3 here, which is 9. And plus 9 minus 8, or 9 minus 1, which is 8. So we get 8 squared. Alright. So now as we simplify, I got the square root of 81 plus 64, which is the square root of 145. So there's D1. Alright. Now let's move on. Let's go to D2. What would D2 equal? So D2, square root, change in x squared. So let's look at the y coordinates with D2. So here are our x coordinates and our y coordinates. Right? So we're going to subtract those values, find the change in x. So I got 2 minus -3 squared plus change in y squared, which is -1 minus 1 squared. And as I simplify, I get 2 minus -3, which again, two negatives make a positive. So this ends up being a plus, right? So we have 2 plus 3, which is 5. 5 squared, plus -1 minus 1, which is -2. As we simplify that, we get the square root of 25 plus 4, which is the square root of 29. So there's D2. And then D3, our final length, right, changing the x coordinates. So we got what? 6 minus 2, subtract subtracting the x-coordinates squared plus the change in the y-coordinates. We got 9 minus negative 1 squared. As we simplify, 6 minus 2 is 4 squared, and we got 9 minus negative 1. Two negatives make a positive, so that makes a 9 plus 1, which is 10. So end up with the square root of 16 plus 100, which is square root of 116. There's D3. So back to our problem, all right? Looking at this problem here, let's go ahead and write in here. So D1 squared, so D1, which was square root of 145 squared, equal to D2 squared, square root of 29 squared, plus D3 squared, square root of 116 squared. Well, as we simplify, that's what? 145 equal to 29 plus 116. And what do we get? We get a true statement. So that implies, yes, we have a right triangle. So our Pythagorean theorem holds true, right? So again, that was our question. It's a right triangle. Pythagorean theorem must hold true, and it did. So again, that's a good review, right, of our distance formula. So remember, distance, d is equal to the square root, changing the x-coordinate squared, plus the change in the y-coordinates squared. So using that distance formula, right, to help us with these and calculating distance. All right. So I hope that helps you a little bit with the distance formula. Now, with that said, let's move on to our next formula introduced, the midpoint formula. Midpoint formula, easy formula to remember. All right, we want to find the point in the middle of a line segment. So we were looking at a line segment. So let's draw in a picture what we're talking about. All right. So let's say we had 2 points, endpoints right here. We got x1, y1, here's point 2, x2, y2. And here's our line segment. We want this point right here in the middle. So to find that point, all we got to do is average the ends. So we average the ends, that's all the midpoint formula is. To find an average, we would add up the x-coordinates, there's 2 of them. So to find the average, we divide by 2. And then, of course, the y-coordinates, they're the ends, we want to get to the middle. We'd average those 2 values, so y1 plus y2 divided by 2. There's your midpoint formula. Right, so just averaging the ends will put us in the middle. So let's go down here to some examples. Find the midpoint of the segment having the given endpoints. So if you want, let's draw a picture. So looking at the xy axis, 7, negative 2, right? 7 down to somewhere down here in quad 4. One of our endpoints. Right 9 up 5. Here's the other endpoint. 9, 5. And there's our picture. So we're looking at, right, our middle point. So we want to find the midpoint, the point in the middle. We're going to go average these ends. So let's find the average. So again, that's x-coordinates. So remember, it's x1 plus x2 divided by 2. y1 plus y2 divided by 2. So that's going to be equal to 7 plus 9, right? If we go to the ends, average those 2 numbers, we're going to get an average of 8, right? That'll be in the middle. And then the y-coordinates, negative 2 plus 5 divided by 2. So again, there's x1 and y1, and up here is x2 and y2. So as we simplify down, I got 16 over 2 and 3 over 2, so 8 and 3 halves, right, or 1 1/2, 1.5. So there's our middle point. So in finding the midpoint, we've got that order pair, 8, 3 halves. There's the midpoint. So again, that's pretty straightforward. right, and find the midpoint. Moving on, let's go to example A, and this will get us into our last topic, which will get us into circles in this last one, or this next one. It says the points -4, -1, and 4, 1 are endpoints of the diameter of a circle. Determine its center. Find the center of the circle. So we got ends of a diameter. So let's go ahead and draw a picture of this circle. So just to get a quick picture, I'm just going to draw in a circle here. And we know from definition of a diameter, diameter connects opposite ends of the circle, the endpoints, right? That line segment that passes through the center, right? It's twice the radius, your diameter. So left 4, down 1, if we were plotting it on the XY axis, that ordered pair would be over here somewhere. And then the other end of this diameter would be the opposite side or opposite end of this circle, right 4, up 1. Right, and as we connect these, there's that line segment that passes through the center. Right, diameter passes through the center, connects opposite ends. So there's the center of this circle, which is equal to what? The midpoint of this diameter. So we got to find the midpoint. So all we got to do is average the ends. So to find the midpoint, we'll take -4 plus 4 divided by 2. And we'll do the same thing with the y coordinates, -1 plus 1 divided by 2. So we end up with 0 over 2 and 0 over 2. We end up with 0, 0 for the center. So again, using my midpoint formula, right? x1 plus x2 over 2 and y1 plus y2 over 2. But there's the center. So we go back to our circle, we can add a little bit of information to it. Here's that point, 0, 0. So there's the center, right, of this circle, which is what they asked for, to find the center. All right, now I'm going to build on and look at our next topic, and that's finding the equation of the circle. All right, now our equation, standard form for a circle. All right, standard form for a circle equation is we have two variables x and y, they're both squared terms. All right, so if you look down here, you see, right, your standard form, you got x minus h squared with y minus k squared equal r squared, where h and k, which are the number of the constants being subtracted from x and y in these two squared terms, they represent the x and y coordinates, the center point. Right? So x minus h squared, so the x squared term will give you the x coordinate, the y squared term will give you the y coordinate. You just need to see the squares of both terms, x and y. If you do, you'll see it right in front of you, those two coordinates. And the right side is the square of your radius. So if we want to find the radius, we're going to take the square root of that constant term, and get the radius. So two key pieces. If we have the center radius, right, we have the circle. Everything need to graph it, and we have everything need to do the equation. So again, standard form, we've got x minus h squared plus y minus k squared equal to r squared. So again, our center, right, center being the ordered pair h and k, right, and r being the radius. So this problem here, we got our center point. So we can write it over here on the side. So this circle, we have a center, right, at 0, 0. So there's h and k. So that implies we got x minus h, x minus 0 squared, plus y minus k, y minus 0 squared, equal to r squared. So what does r equal? So we got a little more work to do to find r. So to find the radius, we can go back to our drawing. Right? Radius is the distance from the center to any point on the circle. So we can use the distance formula. So let's apply the distance formula, right? And we can get the radius. So again, let's find the distance, right, between 0, 0 and 4, 1. So again, we want the radius, find the distance between the center and 0, 0 and a point on the circle. I'll do 4, 1. Alright, so that implies D is equal to, so here's the x coordinates, x1 and y1, x2 and y2. So distance equal to the square root, change in x squared, 4 minus 0 squared, plus the change in y squared, 1 minus 0 squared. So I'll end up with the square root of 4 squared with 1 squared. So the square root of 16 plus 1, or the square root of 17. There's your distance. And it's an irrational number, but that is our radius, right? That will equal the radius in this problem. So again, that's our distance formula. I'll go ahead and label this R. But there's R, the radius value. So we've got the radius now. So as we go back to our circle, right, we can go ahead and plug that in. So as we look at our radius, we got the square root of 17 squared. As we simplify, x minus 0 is just x, so x squared plus, and y minus 0 squared is y squared. And we square the square root of 17, we get 17. So there's our circle equation. And you check it. Now you could plug in your points. For example, check -4, -1. -4 squared was -1 squared, 17. It does check, right? And finding that. So again, center radius tells us everything about a circle. So you can find its equation. So you can do that as you look at one more example. You take this next problem where they got the ends of the diameter given, and you could draw a quick picture of this circle. We don't even need the XY axis. Right? We can just go ahead and draw in the circle. Ends of the diameter, -3, -11, left 3, down 11, be somewhere over here on our circle. I'll go ahead and plot that. Right 7, up 13. Here's 7, 13. As you look at the diameter, right, connects opposite ends of the circle, passing through the center. And again, here's our center of the circle, which we need. We'll get the equation. We need to find the center and the radius, right? That's our first step. Right, find the center point. And then step 2, find the radius. I do it in that order. To me, that's the easiest way to go. So with center, we know, again, that comes from the midpoint. So to find the midpoint, we just find an average. So add up the x-coordinates, 7 plus -3 divided by 2. And then 13 plus -11 divided by 2. And we simplify that down. We got 4 over 2 and 2 over 2. And that simplifies to 2 and 1. And there's your center point. So there's your values of H and K. Right? There's the center of the circle. And now let's get the radius. So I'm going to find R. I'll do it in a different color. So again, the radius would be from that center point, which we just found here. It's just 2, 1. And you can go to either point. And we'll go to 7, 13. So let's find R now. That'll be step 2. As we do that, I'm going to use distance formula. So R equal to square root, right? Let's go ahead and get that. Changing the x-coordinates, 7 minus 2 squared, plus the change in the y-coordinates, 13 minus 1 squared. That's the square root of 5 squared plus 12 squared, which is square root of 25 plus 144. Which is square root of 169, which we can rationalize. Perfect square is 13. So our radius, which is our distance from the center to any point in the circle, is 13 units. So now we got everything to write the equation. So what's our circle equation? So in putting in our answer, put the black here in black. So they've asked to find that circle equation. Let's write out the standard form. So x minus h squared, right, plus y minus k squared must equal r squared. So that implies x minus 2 squared plus y minus 1 squared equal 13 squared. And if you wanted to, now I would not square these. We want to leave them in standard form so we can see the center point. But I would go ahead and square 13. But there is our circle equation, right, for this information. All right, so that's circles. Let's go the other way. We got two more examples. We got example B and C. All right, so if you look in here at examples B and C, these next two, they already give us, right, the equation of the circle in standard form. So we want to go the other way. We want to find the center and radius. That way, if we wanted to graph it, we could. So if you look at this first equation, for example, right, let's rewrite it in standard form. So again, remember our circle equation, right? So standard form is x minus h squared. So I'm going to go ahead and rewrite x plus 2 with a minus. So x minus negative 2 squared. And y, same thing as saying y minus 0 squared, equal to 100. So there's h, there's k, and there's r squared, right? Standard form circle equation. So that implies my center, right, which is my ordered pair h and k, is equal to negative 2, 0. So there's the circle, right, the center. And then the radius, of course, if r squared is equal to 100, right, we need to take the square root of both sides. And what do we get here? We get r equal to 10, right, square root of 100. So our radius is 10 units. And if you wanted, you graph it. So we could take that information, right, and get a quick picture of this graph. So you want to graph in this circle, we could do so now. So let's go ahead and graph this one. Here, example A. So you take negative 2, 0 as the center. So over here, negative 2, 0. All right. Well, if our radius is 10 units, all right, we go up 10 units. And we put them in a different color. So let's say this is up 10 units here. So there's our radius, our distance traveled, r, equal 10. We'd add 10 to the y coordinate. That'd give us a point of negative 210, right? And if we went right 10 units, right, we'd be over here. We would add 10 to the x coordinate. That'd be 8 units on the positive side of the x-axis. Right, so again, moving that distance of 10 units, adding 10 to the x-coordinate would put us at 8, 0. We went down 10 units, right, we'd be down here, right, in our graph, and that's our ordered pair of negative 2, negative 10. And then if we went left 10 units, right, which we could go ahead and do. Let's go ahead and extend this x-axis out a little bit, just to get a little better picture. Get that arrow out of the way. But as we go to the left 10 units, right, we'd be over here at what? Again, r is equal to 10. We'd be over here at negative 12, 0. Subtracting 10 from the x-coordinate. So those are some quick, easy points using a radius. Right, and then we could connect these points to get a quick picture, right, of the circle. So again, that's the graph of the circle, passing through those. There's 4 points, the horizontal and vertical points for your equation. So yeah, this is example B here, right? So again, looking at its information. Here's B. Now let's go down here. We'll take example C, right? So what do we have for C? So C, I've got x minus 7 squared, right? Plus y plus 2 squared. I'll go ahead and rewrite it as a minus. Y minus negative 2 squared equal 25. So there's h. There's subtracted from x, the x coordinate center. There's k, and there's our value of r squared. So that implies our center point, right? The ordered pair h and k is that ordered pair of 7, negative 2. So there's the center of that circle. And our radius, so if r squared is a constant term on the right-hand side, we've got a radius of 5 units. So there's a radius. And you can plot it, graph it if you want to sketch it out. But that's finding the center and the radius. All right, so that's distance, midpoint, and circles. Our 3 topics here from section 1.1.